Hi everyone. This video I'm going to show you how to use a new feature of Circuit Wizard that they put in the latest build. It's a way of easily, or fairly easily, making a box from based around your circuit board that you can obviously check will fit your circuit board and battery and components inside it in a much easier way than using Autodesk Inventor. Now, in this course you're going to learn both ways of designing a box. To be honest, if you can do it, I'd much rather you use Autodesk Inventor because you can do much more impressive things, and when you master the software you'll be more useful to people and you'll make better designs as well, and you'll be more employable. However, if time is a problem or you're really struggling with proper CAD software, you can use the built-in feature in Circuit Wizard, which is what I'm going to show you here. Right, I'm going to do this video aimed at my Year 9 class, so they're going to use it for making their MP3 player boxes. So this is the Year 9 MP3 player circuit board, you might remember it. This same process applies if you're building any box really. Just load your circuit board that you've designed up first. You want your circuit board in here because your circuit board is built to a scale, and then everything you do will be guaranteed to fit. Okay, hopefully it'll all make a bit more sense when you follow the rest of the video. So I guess the first thing to do is, if you are doing the Year 9 MP3 player, you want to go load up this file, which you'll find on the student drive, M drive, under Tech, Mr. Winter, Year 9 Electronics, Year 9 MP3 player project, and it will be called something like MP3 player circuit board. So you can copy and paste that into your user area. If you're a Year 11, 10 or 12, 13 even, that would be embarrassing, and you want to use this method of making your box, then obviously just load up your circuit. What you may need to do is, at the bottom of the page, if your circuit is not already on a slide that's called Design, like I'm circling with a mouse here, you'll need to right click down here, insert a page, and insert a new design. Okay, it has to be in design view. Alright, a few things you need to do to make this run smoother. The first one is, where my mouse is down in the bottom, you want to check that this is set to a scale of 1mm. This is important because sometimes Circuit Wizard sets itself up in 0.025 of an inch. Stupid Americans and their stupid units, but make sure it's set to millimeters. This will make everything much easier and line up easier. The second thing you're going to need to do, this is mainly for my school, so anyone on the internet who's watching this, we tend to use 4mm plywood to laser cut most of your panels from, so we're going to set the default material to that. So you're going to go up to Help, Customize. Annoyingly, on your computers, 3mm acrylic will be set as the default material. We're not rich enough at Collingwood to be able to do that, so if you go down to Plywood 4mm and just right click on it and make sure you select Set as Default, it should have a little star next to it here, like the picture. Please do that. It will mean you don't have to keep changing the material for every single panel you make from now on. Okay? Right, we're going to start. It's a very odd design process, this, if you're used to any other CAD. You basically draw the bottom and top panels and draw rectangles where the side panels that hold the top and bottom together will fit, and then you click a magic button and the software unravels it all. There are a few annoying glitches with it and things that they really should have thought of in the software that I'll explain along the way. Annoyingly, the company don't even produce a tutorial video for this. I should really be getting paid by these guys as well. The number of videos I've done showing people how to use their software. So, New Wave Concepts, if you're out there listening, I could do with a new job, to be honest, so hit me up. Right, anyway, we're going to make some panels. So this, you're basically going to be using these 1, 2, 3 tools here. On the left, this is the one you'll use to start with, so insert a single panel. Now what I'm going to do is I'm going to start by making a boring rectangular box, and then we're going to jazz it up a little bit, and I'm going to show you how to change it to maybe use a different shape, a polygon shape, or even how to import a picture off the internet and use it as the outline for your case. Okay, so let's start with the boring rectangular box. So before you do anything, I would recommend you kind of arrange your components in an efficient way. So there's no point having your battery 3 miles over here. We're aiming to minimize resources, so we want everything compactly laid out together. You may decide you're even going to put your speaker over your circuit board, and if you imagine in the vertical axis, it will just be a taller box to accommodate the depth of the speaker. I'm just going to leave it off to the side for now. You also want to go and get any other components you may or may not have. I'm going to go to off-board components here and input latching switches. So if you're doing the MP3 player project, you'll remember one of the things I added in the design brief was that your project must have an on and off switch, and you'll remember the type we're using is this slidey switch here, double pole double throw slide switch. Okay, so you might as well grab one of those. Get the vertical profile. I'll talk about why you can't use the side profile in a minute. This is important because Circuit Wizard will actually put the holes for mounting these components in. If you want to be really fancy, and maybe you're going to have an LED, so I'm going to go and get a 5mm LED, like so. This is going to cause a problem as well, but I'll explain that later. You might want to drag an LED out. Always go for the vertical view of components. What I mean is like a top-down view. It's the only way it will generate all the parts. Annoyingly, in Circuit Wizard there isn't a model of a stereo jack, so I've had to go and get a picture off the internet to symbolize that, but that will just help you visualize where it might come out of the side of the box. Alright, so get all your components, lay them out in a nice compact way to minimize wasting material. Now, I'm talking a lot, aren't I? Now we can go up here and we can use this to draw our basic shape. So I'm going to get a rectangle and you literally just drag it out. Okay. Now if you've set the default material, you'll notice it looks like plywood. If yours looks like that, it's because, or blue, it's because you didn't set the material. Okay, it has to be set to 4mm plywood. This will become even more obvious later on when we realise it's going to put the tabs and things that slot all these together. Now what you'll have noticed is I can resize this, I can drag my switch around, and you'll notice the little holes for the switch follow it, which is really cool, really useful, saves us having to measure it out. Same for that, same for my speaker, it will all move relative. Okay, so this is great. However, I would recommend you start by making the bottom of the box first and then put the top panel on last. I know that seems a bit backwards, but you can't see what you're doing if you put the top panel on first and then the bottom. Now you're going to need to change something, so double click on your panel and you'll see you've got an option here for which layer should it be on. Should it be upper panel or should it be lower? Now when I build this box, I am going to want my speaker and my light and my switch on the top of the box, but I want to make the bottom first, so I'm going to choose lower panel, click OK, and you'll notice now the panel is behind all the components. I hope you're kind of following so far. Alright, all seems good so far. What I'm going to do now is I'm going to draw the side panels. Please make sure it's set to 1mm again down here. It's also a good idea to have snap to grid turned on. And under the same menu where you found rectangle, if you go down to the bottom you'll find side panel. This is a bit hard to get your head around first until I go through the next few steps and show you what's happening. You are now drawing the side panels, what will become the vertical panels, but from above. So you may need to start drawing and give yourself a little bit of room. I clicked and dragged out a panel there. Okay, I'll just sort of zoom in here. I don't know if you can see that. That's like the wall, the thickness of the panel viewed from above. This little slot hole here is actually going to become a tab. Okay, I'll carry on and then I'll unravel it and show you where it's going. It will all make more sense then. Okay, so I'm going to do the same on this side. I'm deliberately going to do this wrong to show you can correct it. Right, if we look at that, that obviously our notch or panel doesn't quite meet the edge of the work, which looks a bit scruffy, so I'm just going to drag it along a bit till it lines up perfectly. I'm going to draw another side panel between here and here. Okay, and as you can see now my LED is interfering, so now would be a good time to reposition my LED. I'm going to do the bottom panel. I'm going to do it slightly wrong to give you another problem that can happen. I'm going to draw it like that. What you'll notice is these two panels are sharing the same physical space. Now it doesn't take a rocket scientist to work out that won't fit together. You can't have two bits of wood in the same place in a real circuit, so you'll need to make sure you drag the little end adjusters and make sure all the panels touch end to end but don't overlap, and don't overlap the edges. Okay. Right, to make that more obvious what's going on now, I'm going to skip ahead a step and then come back to this. If you go to this tool at the end, the one here, separate panels, click it, you'll get a little wizard appear. I wouldn't bother clicking add dimension unless you're trying to create a drawing to go in your folder work. The only important thing you need to know here is this one, height of the side panels. This basically just determines how much distance will be between your bottom and your top panels. You may need to get a ruler out here, you may need to measure how deep or thick your battery is, you may need to measure how thick your speaker is, or just use a ruler to size up how you might want your box to look. Okay, I'm going to set it to 60 millimeters. Okay, but you can experiment. Click separate, and then voila, what we have got here. I don't know if you can imagine. This might be what you've seen in when you've worked in 2D design or Google SketchUp or Autodesk Inventor. We've got our bottom panel. This would be our long side, which if you imagine will clip into there, but obviously it will be rotated 90 degrees towards me, so it's pointing up. This would go in here, this panel would turn and fit into there, etc, etc. Okay. If you want here on this screen, you can also start rotating panels with the normal rotate tools. Okay, so if you can imagine that would slot into there, but would be turned. I hope you can kind of visualize this. Now obviously this isn't complete, so I'm going to go back and finish it off, and then I'm going to bring you back here and show you how we can get this ready for laser cutting. So you'll need to, you might as well delete the page. Ignore these, I've got two old versions here I'm going to get rid of. You didn't see those. Go back to my design. Alright, so I know I've made my bottom, my sides, and my long sides. I'm going to put my top panel back on now, so I'm going to go, actually, I'm not. Ignore me. No, I am. I love the way I changed my mind. Here we go. Get another rectangle, draw it over there. It'll be the same size, so I'm just dragging it out over the top. Now by default I think it makes all panels top panels unless you specify otherwise, so but as you can see now it's made it top. I've got my holes in it for my speaker, my LED, my switch. If I was to click the separate panels button again, click separate, you'll now see I've got my top, my bottom, my side, my side. Alright, so this is all quite clever so far. And like me, you're probably thinking, wow, why is Winter teaching us Inventor when we can do it like this? Well, you'll realise there are some incredibly frustrating things with this. And I will show you them as follows. So I'm going to delete those panels again and go back to my design. Temporarily, I'm just going to click and drag my top out of the way so I can see what I'm doing. Now you will remember, one of the things that I mark you on when you design boxes is I insist you put an access panel into your box, like a hole that you can get to your circuit board and your battery to fix it and replace it. And this is no different. But a hole is made with these tools here. It's called the cutout. So what I'm going to ask you to do is get a rectangle, and you can, obviously you need enough space to access your battery, your circuit board, and maybe to install your speakers. So I'm just going to drag out a rectangle that I think is large enough here. I'm deliberately going to make it that big because you guys are going to see a problem with this when I convert it. Now there's a little issue here. What you'll notice is that looks great. It looks like my access panel's there in the back. If I drag my top panel back in place again, can you see what's happened? It's actually made my hole, the hole for the battery access, it's made it in the top panel and the bottom panel. I don't want that. So you're going to need to go back to your little rectangle you just drew. Might be a bit hard to select, so zoom in if you need to. Double click on it and you'll get an option. Where do you want to cut the shape out of? Well, I only want to cut it out of the lower panel. So untick upper panel, click OK. It doesn't appear to change anything, but when you drag the top back now, you'll notice there is no hole in the top panel. There is only a dotted line, which in engineering drawing symbolises hidden detail. So there is a hole in the rear panel. Right, I'm going to unfold this now, and we should see an obvious flaw with it. You may have spotted it already. Unfold it, separate. Right. Hopefully you will notice incredibly thin piece of wood between that hole I made and the little notch I cut out. That is obviously not going to work if we put it in the laser cutter. If you put that in the laser cutter, the laser will just vaporize that little bit. There'll be nothing left. So we need to rethink our design. We could either make the hole smaller or we could make the whole box bigger. So this is where it's nice and easy and a bit friendlier than Inventor to change. I've decided, let's move that panel out of the way. I need a bit more room, so let's make the whole box a bit taller here, a bit taller there. Drag my sides back down into position. Okay, readjust everything, make a bit more room, put that back, drag that a bit bigger. As you can see, it's still possible to make mistakes here if you're not paying attention. Put that back. That will obviously need resizing as well. Bosh. Annoyingly, this doesn't auto-update. So every time you've got to delete the old panels you made, go back to design and re-separate them. Okay, right. That is now a bit more sensible. That's going to have some strength to it. Okay. You will also have to watch out for other things here. Can you notice here I didn't drag this tab far enough over? If I go back to design, can you see this isn't quite sat on the edge? So maybe pull it back over, delete that, go back to separate. Okay, that's fixed that bug. Right, now I'm going to show you some of the limitations of this software. I played with this and I thought, you know what, that's bloody brilliant. I love this software. These guys are really good. And then I thought, you know what, it'd be ace. What if I didn't want my switch on the top, but I wanted it on the side panel, and I wanted my LEDs sticking out the side? I thought, oh, I know what they'll do. You just go get the red LED, and you'll sort of stick it lined up on the side, and then you might go and get maybe under switches. They've gone and put a nice sideways version of the switch, so they've obviously done this on purpose, so I'll go and put my switch there like that. Okay, I'll just delete that for now. And you think, right, so I've lined my switch up with a panel as you'd expect it to look, line my LED up with a panel, wicked. Now if I click unfold, surely it'll put the holes in the side panels. Guess what? Separate. No, it doesn't. Stupid, stupid programmers. You missed a really, really important trick there. You could have sewn up the educational market for this bit of software, and every teacher in the land who teaches electronics would be buying it. But now they're going to be angry because you didn't make it possible to put holes through the sides, you stupid people. If you're listening to this, please add that feature. So anyway, I'm going to delete those. Thankfully, you can go and put the holes in yourself. It's just a bit frustrating. Why should you have to? So if you need to do that, separate your panels out, and on this view you will have to use the hole tool and draw them on manually. So if it was an LED, click circle and you just drag it out, and it's a bit hard. If you notice sort of down here where the mouse is, you'll see numbers. Those numbers indicate the size of your shape. Now an LED would be a 5mm hole, so you'd put 5, well, it's actually a bit harder than that. 5 by 5 is actually the size of the square, I believe it would fit. I'll need to check that because I don't think that's the right size for an LED somehow. I think what they're giving you is radius rather than diameter. So if you wanted a 5mm hole for a 5mm LED, you'd actually need a 2.5mm hole, because this is a 10mm hole at the moment. I can prove that if I get the dimension tool here. Sorry if I'm getting a bit confusing. Linear, and just sort of estimate that look from there to there. As I suspected, is 10mm. So your LED will just fall out of that. Obviously, 2.5mm, you're going to have to go and adjust your scale. You're going to have to set it down to 0.5mm spacing. And now if you draw your circle as a whole, and make sure your little numbers down there say 2.5 by 2.5, just to prove that, if I adjust my little dimension here to check it out, and this is worth you doing, you'll see that says 5mm. Okay, so hopefully you can do that. I haven't got the option in this video to list all of the sizes of all the components. The one I will do for you, because most of you in the MP3 player project will be using a switch. The on and off switch you're going to be using, I can remember it off by heart, this is so tragic. Get yourself a linear dimension, and say you wanted to put it on this side panel, draw me a 28mm line. This is frustrating in itself because you will have to manually adjust this until it says 28. Get the circle tool, so make a circle hole. At the lined up on one end, draw yourself a 1.5 by 1.5 circle. Do the same on the other end, 1.5 by 1.5. Then get a rectangle and draw yourself pretty much in the middle, a 12 wide by 6 high, remember look at your numbers in the bottom right there, rectangle, and then you need to drag and position that equidistant, so it should be, I'll just move that along a little bit to the left, should be the same distance up and down and left to right, and delete your dimension. Okay, if you follow those instructions, your hole for your slide switch will be perfect. Okay, so this is one of the annoying bugs of the software, that you can't put components in the sides easily. I know why they cheaped out on it. It's because each component you would have to have specified how high off the ground you want it, but I don't think that would have been a massive ask to add in. Okay, so anyway, you can modify your parts here. Those of you who've built a box in a project with me before will know that there's a few other things you're going to need to do. We're going to need to build shelves to hold the battery door. If you can imagine, there will be a panel that will be sitting in here. You don't need to make it separately. If you think about this logically, if I sent that shape to the laser cutter, it will cut all of this out of wood, and the piece of material that falls out of this hole in the middle here will become this bit of wood here. So you don't need to make it separately. Let's save the trees, man. What you do need to do is make 2 little shelves to sit underneath that door to hold it, for it to rest on and for you to put your screws into. So I would recommend you get a rectangle and just sort of roughly size it up. Draw it over your borders in the background, so there'll be one here. I'm going to copy and paste. I just did Control C, Control V, and I'd have another panel here. I can just sort of check, do they look like they overlap enough? If you're not sure, you can always right click them, arrange, send to back, so that kind of puts them behind here and you can see the outline a bit better. But I'm happy with the size of those, so I'm going to drag them out and compile them for my laser cutting. Okay, so that is everything I need to send to the laser cutter. So I guess if you've got no ambition or creativity or personal drive or will to succeed and do well in life, you could just stick with that. You could stick with a lame, boring rectangular box. Oh yeah, don't forget a hole in the side for your stereo jack. Alright, I'll leave that up to you. So one of those would need a hole. Go with a 10mm hole, which would be 5x5. However, what if you want to do something more interesting? Well, let's get this front panel out of the way now. Some of you might have seen my little astronaut project that I made, the ready-made one, the one I've shown you in class. Hopefully you know what I'm talking about. Maybe I want to have a boring box on the back, and then I want to draw something a bit more interesting around the outside. So I'm going to attempt to do that here. Now there's 2 ways of doing it. I'm going to basically keep a square back panel, square sides, and then I'm going to draw an interesting shape over the front of it. You can go here and you've got polygon, which is quite cool. So polygon just allows you basically every time you click to use straight lines to draw a more interesting shape. Okay, so there we go. That could now be my new front panel. So I've got a kind of box hidden behind it and I've got this shape on the front. I can do the usual, click separate, separate, and there we go. That's my new design. Annoyingly as well, guess what you lose every time you separate? All of that stuff, look. All of those have gone missing. So I'd advise you put your screw holes in on side panels and whatever as the very last step you do. So you can do that. I believe you can also combine shapes. So let's say we wanted to make an astronaut by hand. You could maybe get a circle. I think you can get a rectangle as well. So I think you can do something like this. And then I believe, I may be wrong, I thought there was a way of combining them. I honestly can't remember how to do it now. We'll come back to that. I'm sure there was a way of cutting one shape out of another, but I've completely forgotten how to do it, so we'll just gloss over the fact that I'm an idiot for now. However, so yeah, maybe we can do something like that. And I'm just going to pause the video, see if I can figure it out. Hold on. Look, I never fail you. I've figured it out. I'm brilliant. Something else that might be quite cool, if you've got what I call a primitive shape, a basic shape like this, you can right click it go to shape and click flatten shape, and this turns it into a bunch of polygons, so you can just kind of customize it. So that's quite cool. So I don't know what we're making here. What you can also do is if you hold down shift and select both shapes at once, if you right click on it, go to transform, and here if you click add, it will combine those two outlines together. If you click subtract, it will cut one out of the other, or any of these I haven't really messed with, but I'm going to click add, and you'll see that's made it into one constant outline, and I believe you can then shape, flatten shape, well, do whatever it is. Okay, so you could build up an interesting outline like this fairly easily with a bit of time. Okay, that might look a bit cooler. I'll just show you again. Let's add on my own polygon on the bottom of my own design. Okay, I want to combine them, so click, hold down shift, click, right click, shape, arrange, transform, add. There we go. Now I might want to rotate that left, so you just use your rotate tools. So you see what I mean? Why this company is stupid. They've made a really easy to use bit of software and then screwed it up at the last hurdle by not adding in that ability to add holes on the sides. Right, there we go. So that's great. I'm happy with that now. Again, usual, click flatten, separate, and I've got all my panels. Nice. I can see my slots, I can see it all fits together, whatever. Okay. The final trick I'm going to show you, what if you are lazy or just basically unskilled and can't draw very well, even on the computer, and you want a picture off the internet? First of all, I'll show you there are some nice built-in models, although they're a bit boring. Well, a bit samey actually. So if you go here, you've got import bitmap. It will, no, it's not doing it now. On your computer, it will take you to a folder, hopefully, where there's some ready-made files. It's things like guitars and weird little furry alien things that came with the software. That's not very interesting. So what you can do is you can go onto the internet land, and whatever you search for, obviously don't make sure it's not offensive, but I would suggest you search with kind of the words cartoon or illustration and white background, because you want a very simple, bold, clear picture for this to work well. Okay, so for instance, I've picked cartoon astronaut there. I'm going to go cartoon T-Rex white background, just because my kid's really into dinosaurs at the moment. That's not really a cartoon T-Rex, is it? What is this? Okay. Right. Oh, look at that guy. He's pretty cool. Right. So what you want to do is you want to copy this. Now, annoyingly, it has to be a bitmap image, BMP. That's not BNP for anyone claiming I'm a racist. That's BMP. Save link as, copy the image. So you want to copy that. And the easiest way to convert an image into a bitmap is to go into Microsoft Paint. Okay, I've got it loaded here. You can just find it in Windows. Hopefully you know how to find Paint. If you don't, what have you been doing with your life? And paste it into Paint like so. Control V. You may need to zoom out and check it fits the whole page. You may need to adjust your page to crop out any anti-piracy measures. You know, we're all about the copyright infringement here. Anyway, once you've got your picture, File, Save As, BMP, bitmap picture. Okay, I'm just going to save it to the desktop, so I'm going to call it Dinosaur Original, I know. And then in here, when you go here, you click on Import Bitmap, you go and find a dinosaur, and you may be surprised at first you may see nothing on your screen. If you see nothing in this window here, you will need to drag this little adjuster doohickey left and right until you get a nice outline. Now all this will do is produce an outline. This box here that says mask, by the way, if you've searched for white background, leave that set to white, and what it does is it cuts out anything that's white and leaves you with the shape in the middle. Okay, anyway, you'll see what happens if I click import. You'll see that has made my T-Rex. It will add in all the graphics as well, as an outline. Now it gets a little bit tricky here. You'll notice the T-Rex is huge. Alright, if I was to leave it like that and convert my panels, separate, you can see I've got my nice T-Rex body, but it's a big waste of material. It really doesn't need to be that big. So annoyingly, you can't just grab a corner and shrink it, because this is actually, if you see what that's done, that's just annoying. Hopefully you saw what it's done. It's just tweaked the corner there. Okay. What you can do to get it to the size you want is select it. I'll just unselect that quickly. And oh no, what am I doing? I'll just click on it. Right click and transform scale, and then you just type in. So if you typed in 0.5 by 0.5, that would make it half of the size it is now. Okay, that's a bit more realistic. Ignore the fact that it doesn't scale the graphics. I don't know why it does that. There might be a way of clicking it and going to artwork and clicking center or something. I've not quite figured this bit out, but I'm not bothered about the pictures because we can't transfer the picture from the laser cutter anyway. You might look at all this and go, well, that would be better if it was vertical, so I'm going to right click, arrange, and I'm going to group all of that first, and then once it's grouped you can't rotate it, which is awesome. Maybe I can rotate this guy instead. Alright, so maybe it's easier to rotate the dinosaur. Okay, position that over there. I can now do my unfold thing, separate. There we go. So I've got my nice dinosaur outline. I've got that, I've got that, I've got that, I've got that. The good thing is, in here, if you figure out the artwork issue, I believe you can print that in colour. So you could, you know, print that and stick it to your design, or somehow use it to engrave outlines onto your picture, or you could just print it and try and paint it on by hand afterwards. But there we go. That's the basics of the software. For the rest of what I want you to do as my students, I want you to make this, obviously put in any holes, put the shelves back in that we were talking about back here. Okay, you know, so the 2 battery shelves. You may be able to copy and paste stuff. Let's have a look. Does that work? So hold down Shift, Control C for copy, Control V. Oh, that's sick. Look at that. So you can copy and paste stuff from previous prototypes. So I'm going to copy those in and put them here. I then want you to tessellate the bejesus out of this. Tessellate, if you're unfamiliar with that, let's do our numeracy link for today. We love a bit of that. Tessellate means to make shapes fit together in the most kind of efficient way possible. We're doing that to save laser cutting material. Okay, so rotate bits. You might be tempted to put that bit inside of here, but don't do that, because remember, you're going to need the bit that comes out of there to be your battery door. Alright, so really just get these as close as sort of sensibly possible to minimize material, and make it as rectangular as possible so the technician has an easier time laying it out on the machine. Okay, apart from that, obviously save your work regularly. You will then need to, I believe you go to, once you're completely done and proven, what I need from you, or what the technician needs, is you to go to File, CAD/CAM, Export DXF. Basically leave it as it is. Make sure it's set to millimeters just in case, and then save that file somewhere, and that is the file that you need to email to me or the technician. Okay, that's it. I know that was a long video, but compared to learning Inventor to build a box from the ground up, if you struggle with that, this can be quite easy. Alright, there we go. Any questions, please direct them to, well, it'll be me basically, won't it? Let's be honest. So yeah, put your hand up, whatever it takes. Alright, until next time, goodbye.